Hi guys, in this video I'm going to show you how you can work with a control system package library. So the first thing to do is to clone an existing GitHub repository control system package into your project. So I will work with PyCharm and we'll move to Visual Studio Code to work with C++ code. So first, and I guess the easiest thing to do is to import your project from GitHub simply by cloning it. You can do it like this, but as you can see the directory already exists, so we just simply go inside of it. And here you may find the double pendulum py file. It is our example how you may use your how you can use our mechanical system code with your own systems. So the first thing to notice is that here we import an early Lagrange py file. And as you can see, this file consists of a class mechanical system with different parameters. And it also has a get Lagrange equations functions, which brings us the result of our computation and returns the Lagrange variables, so our output. And as you can see, first we initialize our mechanical system with generalized coordinates, initial generalized coordinates. It is θ1 and θ2 in symbolical form. Then we calculate the kinetic energy of our system and set this parameter to our double pendulum mechanical system. We do the same thing for potential energy and for the friction. And after that we simply calculate get Lagrange equations function, and it initializes the Q, D and P parameters of our system. And we can see the obtained result here. As you can see, these are equations of motions, inertia matrix and generalized momentum. It's our result in symbolical form. Also, we have a possibility to work with C and C++ code. We included three functions. Create headers, which creates C headers, numerical combined, numerical Coriolis, numerical inertia, numerical momentum, and numerical potential. And these functions simply can return you a numerical result of the same equations of motions or equations of matrix, of inertia matrix. So you can obtain a numerical result of these symbolic functions. You can simply import these headers into your C code and use them freely. We also have a create C++ file function, which creates a C++ class, including all these functions which we have talked before. And we have PyBind model, which we'll talk about a little bit later. So now when we understand how our Py file works and how we can obtain the equations for Lagrange function, we can go to C++ file. Now it is time to see how we can use our generated C++ classes and headers into C++ code. So I've created a simple program, and now it's time to check if the class import is correct and we can use our numerical functions in the C code. So let's initialize our array and let it contain just zeros. Then we will simply use numerical. Let's choose a random function from the class, for example, numerical combined. Let's initialize it with some random numbers, I don't care which one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is sufficient. And the last variable to put is the array where we will store our values. Now let's use print to check if everything works correctly. And let's print out the first value of array result. Now let's run the code and see the output. It is the numerical value of the combined variable of a Lagrange function. So that's basically it. You can easily use the numerical interpretation of this function in C or C++, and you can use the analog in Python using our mechanical system class in the Python. So that's all for today. You can find more information in the GitHub, and I will see you next time when we add our next feature, PyBind model.